The Earth has seen its fair share of mass extinctions throughout its history. These catastrophic events have resulted in the loss of countless species of plants and animals, forever altering the course of life on our planet. The most famous mass extinction event is the one that wiped out the dinosaurs some 65 million years ago. Scientists believe that a massive asteroid impact was the cause, leading to the extinction of around 75% of all species on Earth. But how did that asteroid find its way to Earth? Did Jupiter play a role in it? In this video, we will talk about whether we can blame Jupiter for the extinction of dinosaurs or not. Mass extinction events on Earth. A massive cosmic collision is one of the most serious existential dangers to life on Earth. An intense enough impact with Earth, typical of objects a few kilometers or bigger in size, might easily produce a mass extinction event and may perhaps utterly sterilize the living globe, putting an end to a multi-billion-year cycle of life. For billions of years, these events have occurred across the universe, including in our solar system. It has traditionally been believed that the solar system is favorable for life with the help of Jupiter, which acts as a shield against objects that could impact Earth. Jupiter, the largest planet in our solar system, experiences collision much more often than Earth, serving as its protector. However, this understanding is incorrect. Its existence, in fact, increases the likelihood of collisions on Earth, and researchers estimate that there's a high chance that the KPG extinction event would not have occurred without Jupiter's presence. Previous impacts of Jupiter. Out of all the big celestial bodies that orbit the Sun, Jupiter is the one that gets hit the most. The telescope was only used for astronomical purposes in the 17th century, and despite its basic nature, the first suspected impact on Jupiter was noticed as early as 1690, when Giovanni Cassini's views of Jupiter showed a darker zone that lasted for 18 days. Jupiter would be affected significantly more often than Earth because of its massive size, 125 times the surface area of Earth, and high gravitational pull, approximately 318 times as strong as Earth's. This has been confirmed over the past 45 years, starting with Voyager 1's flyby in 1979, which captured the first bolide striking Jupiter. In 1994, comet Shoemaker-Levy 9 collided with Jupiter, leaving scars that lasted for months, further solidifying this understanding. Since then, 10 more impacts on Jupiter have been recorded. From studying comets alone, it can be inferred that Jupiter is likely to experience a significant impact event similar to the Shoemaker-Levy collision every 500 to 1,000 years, whereas Earth is only likely to experience one such event every several million years. However, it is important to note that the extinction of dinosaurs was not caused by a comet, but by an asteroid, as evidenced by the widespread layer of iridium-rich material found globally from that time period. With observations from the crater Chicxulub created by the impact and the abundances of the elements that were deposited by the impact, we can confirm that an asteroid caused the extinction of dinosaurs. So what about asteroids that are located inside Jupiter's orbit? Centaurs that are located outside Jupiter's orbit but inside Neptune's orbit? Trojans that orbit around the L4 and L5 Lagrange points of Jupiter, and other objects within the solar system? Does Jupiter truly provide protection to Earth from these objects, as been commonly believed, or does it paradoxically increase the likelihood of impacts? It may seem logical to determine the answer by studying the objects that currently exist in the solar system, without the presence of other large bodies. It is logical to assume that the small, low-mass objects in the solar system would continue to travel along their random elliptical paths until their orbits were affected by the gravity of other bodies, making them potential hazards to Earth. There are certainly many groups of objects that Jupiter effectively prevents from approaching Earth. Every object that collides with Jupiter is no longer a threat to Earth. Trojan bodies orbiting in front of or behind Jupiter are kept away from Earth by Jupiter's presence. A large group of asteroids called the Hilda group, which numbers over 5,000, is directed by Jupiter into a 3-to-2 resonance with the giant planet, keeping them at a stable distance of about 600 million kilometers from the Sun. Taking all of this into consideration, it is evident that Jupiter does provide some level of protection to Earth. Jupiter's overall role in affecting asteroids. However, do these protective effects outweigh the negative impact that Jupiter's presence has on Earth? For a long time, it was commonly believed that Jupiter's main role was to guide asteroids away from Earth, keeping it relatively safe. Many even believed that the presence of a Jupiter-like planet was necessary for the stability of life on Earth-like planets. It was believed that complex, diverse, and intelligent species like humans would not be able to evolve on planets that are frequently hit by extinction-level events. Some wondered, if it wasn't for Jupiter's protection, would it have been possible for us to exist? But that may not be the correct question to ask. After all, any object that exerts a gravitational force has the ability to alter a stable orbit, whether it be planets, moons, asteroids, or smaller masses, redirecting its trajectory from one that does not intersect Earth's orbit to one that does. The question is not whether it's possible for intelligent life to exist without a Jupiter-like world, but whether Jupiter is truly protective of or destructive to other worlds within its system, whether it's an ally or an enemy. The scientific way to think about this is to model a wide variety of objects at various locations throughout the solar system and see how they evolve as parameters like the presence or absence of a massive planet, and how that planet's properties like mass, orbital eccentricity, and a position in the solar system all affect the number of impacts one would expect on a planet located where Earth is. This idea was first explored by John T. Horner and Barry Jones in 2008, where they simulated the number of impacts that would occur on Earth over time from perturbed objects within the asteroid belt. They varied the mass of Jupiter and also considered the scenario where it was not present. In 2009, they continued their research by studying the effects on the Centaur population of objects, and in 2011 they expanded their study by including variations in not only the mass of a Jupiter-like planet, but also in its orbit eccentricity and inclination. This research revealed something groundbreaking, challenging the assumptions that we had previously held. There are situations where, in the long term, a giant planet can have a net protective effect, but there are also many scenarios where a giant planet can create a more hazardous environment than if it were not present. When we consider all these factors, such as mass, eccentricity, orbital inclination, etc., for our actual solar system, what do we learn about the rate of catastrophic impacts on Earth? This means that over 70% of all Earth-crossing and Earth-striking asteroids would not exist without Jupiter. It also suggests that Saturn, despite being twice as far from the Sun as Jupiter, plays a more significant role in directing Centaur-like and comet-like objects from the outer solar system into the inner solar system, and may even play a major role in altering the asteroid belt. Furthermore, it implies that only a massive gas giant with a high orbital inclination provides a net protective effect, and that any other type of gas giant planet would increase the impact rate on Earth rather than provide overall protection. In simpler terms, Jupiter is not a protective barrier. Jupiter-like planets do not safeguard the inner planets of a solar system, but rather increase the risk. The presence of a Jupiter-like planet increases the collision rate from the asteroid belt by more than 3 times what it would be without such a planet. Additionally, all gas giant planets in our solar system assist in bringing in material from the outer regions of the solar system, potentially bringing water and organic molecules to a young Earth's surface. Based on these studies, it's reasonable to conclude that about 72% of all asteroids that have ever struck Earth, including the one most likely responsible for the 5th mass extinction on Earth, would not have struck if it weren't for Jupiter's influence. Despite Jupiter's large size and tendency to attract objects towards it, it has a net destructive effect on Earth by significantly increasing the collision rate from asteroids. Furthermore, all the outer planets, particularly Saturn, increase the impact rates from comets and centaurs, putting Earth at further risk. The belief that Jupiter has a protective effect on Earth is a myth that has been disproved by scientific research. However, that doesn't mean that having gas giants isn't beneficial for the formation and development of life on inner terrestrial planets. The combination of enhancing the early bombardment of pristine, volatile-rich material, including water and organics, increasing the extinction-causing impact rate, creating new opportunities for the surviving life, and the potential to decrease the overall impact rate at late times, which doesn't happen on Earth but may happen elsewhere, could result in the emergence of advanced, intelligent life forms on a world similar to our own. Even though Jupiter is likely responsible for the impact event that wiped out the dinosaurs, the rise of mammals and our own existence might mean that we should give it credit instead.